Article 408.31 of the National Electrical Code addresses the requirement for spare spaces or circuit breakers in panel boards and load centers. This article is important because it ensures that electrical systems have the capacity for future expansion and modifications without requiring a complete overhaul of the existing infrastructure. The core requirement states that panel boards and load centers must have spare spaces or circuit breakers to accommodate future expansion. This requirement is further detailed in two specific provisions. Firstly, panel boards must have not less than 2 spare spaces or circuit breakers per panel board. This means that regardless of the size or application of the panel board, it must always have at least 2 unused spaces or breakers available for future use. Secondly, load centers must have not less than 4 spare spaces or circuit breakers per load center. This requirement is more stringent for load centers, reflecting their typical use in residential or light commercial settings where future electrical needs are more likely to arise. The purpose of these requirements is multifaceted. One key purpose is to prevent the overloading of existing circuits. Where new electrical loads are added to a system without proper planning, existing circuits can become overloaded, leading to overheating, potential fire hazards, and nuisance tripping of circuit breakers. By providing spare spaces or breakers, the code encourages the addition of new circuits to handle new loads, thereby avoiding overloads on existing circuits. Another purpose is to facilitate future modifications and additions. Electrical systems are not static. As technology evolves and user needs change, modifications and additions to the electrical system become necessary. Spare spaces or breakers allow for these changes to be made quickly and easily without disrupting the existing electrical system or requiring extensive rewiring. Furthermore, spare spaces and breakers contribute to the overall safety of the electrical system. Overloaded circuits are a leading cause of electrical fires. By ensuring that there is adequate capacity for future expansion, the code helps to minimize the risk of overloads and electrical fires. Additionally, having spare breakers readily available allows for quick replacement of faulty breakers, minimizing downtime and ensuring continuous operation of critical circuits. The specific wording of Article 408.31 is very precise to avoid ambiguity. The phrase "not less than" ensures that the specified number of spare spaces or breakers is the minimum requirement, and additional spaces or breakers may be necessary depending on the specific application and anticipated future needs. The distinction between panel boards and load centers is also important. Panel boards are typically used in commercial and industrial settings, while load centers are more common in residential and light commercial applications. The different requirements for spare spaces or breakers reflect the different usage patterns and anticipated future needs in these settings. To fully understand and apply Article 408.31, it's important to know the definitions of panel boards and load centers as they are used in the NEC. A panel board is defined as an assembly of buses and automatic overcurrent devices equipped with or without switches for the control of light, heat, or power circuits, designed to be placed in a cabinet or cutout box placed in or against a wall or partition and accessible only from the front. A load center, on the other hand, is a type of panel board designed for use in residential or light commercial applications, typically with a lower amperage rating and a simpler design. The requirements of Article 408.31 are mandatory, meaning that they must be followed in all electrical installations subject to the NEC. Failure to comply with these requirements can result in co-violations, fines, and potential safety hazards. Electrical inspectors will typically verify compliance with Article 408.31 during inspections of new electrical installations and modifications to existing systems. The inspector will check to ensure that the required number of spare spaces or breakers are present and properly labeled. In addition to the minimum requirements of Article 408.31, there are other factors that should be considered when planning for spare spaces or breakers. The anticipated future needs of the electrical system should be carefully evaluated. If there is a high likelihood of future expansion or modifications, it may be prudent to provide more than the minimum number of spare spaces or breakers. The type of electrical loads that are likely to be added in the future should also be considered. If the future loads will require specialized circuits, such as those for electric vehicle charging or high-power appliances, it is important to ensure that the panel board or load center has the appropriate capacity and features to accommodate these loads. The physical location of the panel board or load center should also be taken into account. If the panel board or load center is located in an area that is difficult to access or where space is limited, it may be more challenging to add new circuits in the future. In these cases, it is especially important to provide adequate spare spaces or breakers. The type of building in which the electrical system is being installed should also be considered. Commercial and industrial buildings typically have more complex electrical systems and greater potential for future expansion than residential buildings. As a result, it may be necessary to provide more spare spaces or breakers in these types of buildings. The requirements of Article 408.31 are not static and may be updated in future editions of the NEC. It is important to stay current with the latest edition of the code and any applicable local amendments to ensure compliance. The NEC is typically updated every 3 years, and it is the responsibility of electrical contractors, engineers, and installers to be aware of any changes to the code. The interpretation of Article 408.31 can sometimes be subject to debate, particularly in complex or unusual situations. In these cases, it is helpful to consult with a qualified electrical engineer or inspector to obtain guidance on the proper application of the code. It's important to document all decisions regarding spare spaces or breakers, including the rationale for the number and type of spaces or breakers provided. This documentation can be helpful in resolving any disputes or questions that may arise in the future. In addition to the specific requirements of Article 408.31, there are other related sections of the NEC that may be relevant when planning for spare spaces or breakers. Article 220 of the NEC provides requirements for calculating electrical loads, which can be helpful in determining the appropriate size and capacity of the panel board or load center. Article 312 of the NEC provides requirements for the installation of cabinets, cutout boxes, and meter socket enclosures, which can affect the available space for adding new circuits. Article 408 of the NEC, in general, covers the requirements for switchboards, switchgear, and panel boards, providing additional context and guidance for the installation and operation of these components. Article 110 of the NEC provides general requirements for electrical installations, including requirements for working space around electrical equipment, which can affect the accessibility of the panel board or load center. In summary, Article 408.31 of the National Electrical Code requires the provision of spare spaces or circuit breakers in panel boards and load centers to accommodate future expansion. Panel boards must have not less than 2 spare spaces or breakers, while load centers must have not less than 4. These requirements are intended to prevent overloads, facilitate future modifications, and ensure the overall safety of the electrical system. Compliance with Article 408.31 is mandatory and is typically verified during electrical inspections. When planning for spare spaces or breakers, it is important to consider the anticipated future needs of the electrical system, the type of electrical loads, the physical location of the panel board or load center, and the type of building in which the electrical system is being installed. It is also important to stay current with the latest edition of the NEC and to consult with qualified professionals when necessary. By following these guidelines, electrical systems can be designed and installed to meet current needs while also providing the flexibility to adapt to future changes and demands. This proactive approach ensures the long-term reliability and safety of the electrical infrastructure. Furthermore, proper planning for spare spaces and breakers can save time and money in the long run by avoiding the need for costly and disruptive upgrades when new electrical loads are added. It also contributes to the overall sustainability of the electrical system by reducing the likelihood of premature obsolescence and the need for complete replacement. The requirement for spare spaces or breakers is not just a matter of code compliance, it is also a matter of good engineering practice. A well-designed electrical system should be able to adapt to changing needs and demands over time. By incorporating spare capacity into the initial design, engineers and installers can ensure that the system remains functional and safe for years to come. In addition to the specific requirements for spare spaces and breakers, the NEC also includes requirements for labeling and documentation of electrical systems. Panel boards and load centers must be clearly labeled to indicate the circuits they serve. An accurate documentation of the electrical system should be maintained for future reference. This documentation should include information on the location of spare spaces and breakers, as well as their intended use. The NEC also includes requirements for the protection of electrical equipment from overcurrents and short circuits. Circuit breakers and fuses are used to protect electrical circuits from excessive current, which can cause overheating and fires. It is important to select the appropriate size and type of overcurrent protection device for each circuit to ensure proper protection. The NEC also includes requirements for grounding and bonding of electrical systems. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent protection device to trip and energize the circuit. Bonding ensures that all metal parts of the electrical system are at the same potential, reducing the risk of electric shock. The NEC is a comprehensive set of standards that covers all aspects of electrical installations. It is developed and maintained by the National Fire Protection Association (NFPA), and it is updated every 3 years to reflect changes in technology and best practices. The NEC is widely adopted throughout the United States and is considered to be the authoritative source for electrical safety. In addition to the NEC, many local jurisdictions also have their own electrical codes and regulations. These local codes may be more stringent than the NEC in some areas, and it is important to be aware of any applicable local requirements. Electrical installations should be performed only by qualified and licensed electricians. Electricians have the training and experience necessary to install and maintain electrical systems safely and in accordance with the NEC and local codes. It is important to verify that an electrician is properly licensed before hiring them to perform any electrical work. Electrical work can be dangerous, and it is important to take precautions to avoid electric shock and other hazards. Always turn off the power to a circuit before working on it, and use appropriate personal protective equipment such as gloves and safety glasses. If you are not comfortable performing electrical work yourself, it is best to hire a qualified electrician. The NEC is a complex and ever-evolving set of standards, and it is important to stay current with the latest edition of the code. By following the requirements of the NEC and working with qualified professionals, electrical systems can be designed and installed to be safe, reliable, and adaptable to future needs. The importance of Article 408.31 cannot be overstated, as it directly contributes to the safety and functionality of electrical systems in various settings. By mandating spare capacity, the code ensures that electrical systems can evolve and adapt without compromising safety or requiring extensive and costly overhauls. The 2 and 4 spare space requirement is a minimum and not a maximum.